All right, so we're going to start our first video here, 7.3. We're going to be talking about triangle similarity. So in this unit in general, we're not going to emphasize proof like we did in chapter 4. We're just going to be talking about demonstrating that triangles are similar. So we're going to learn about a couple shortcuts that we can use that don't require everything that the polygon similarity that we learned about previously required. So hopefully you guys remember similar polygons have kind of two aspects to them. One, all of the angles that are corresponding are congruent to each other, and then all of the sides that are corresponding are proportional. Uh, but turns out for triangles, we can actually get away with a little bit less information. Um, this is very, very similar, again, to all of the triangle congruence shortcuts we had. So in that, we had, there were 5 of them. They were side, side, side. So these were triangle congruence: side, 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 angle, side, side, angle, 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 side, and hypotenuse leg. So these were the 5 triangle congruence shortcuts. And we're going to have 3 similar-ish ones for similarity. I said similar and similarity. I always get that. But we have angle, angle, side, 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 angle, side. So there's only going to be 3 of them. And they do work just a little different than triangle congruence. So I'll hope to emphasize that as we kind of go through each of these. So the first one is angle, angle similarity. So it says that if 2 angles of one triangle are congruent to 2 angles of another triangle, then they are similar. So in this picture, we have some triangles. Angle A and angle D are congruent. Angle B and angle E are congruent. Therefore, these triangles are similar. So turns out AA is enough for us to say that we have similar triangles. We don't need to know anything about the sides. We can just use two angle pairs. Kind of cool, kind of convenient. This one is probably the most used. If I had to kind of just pick one, angle, angle is probably the one that we'll use more often than the other. Let's go ahead and look at an example of applying this. All right, so we're supposed to verify that these 2 triangles are similar, and we're going to try to use AA. So we're going to try to use angle, angle. Angles are great. We know a lot of different angle relationships that we've learned throughout the units here. So we know about vertical angles, for instance. There are some in this picture that are vertical angles. We know about alternate interior angles. We know about corresponding angles. All kinds of stuff like this. So in this picture, we actually have 2 of these 3 things. We have some vertical angles right in here in the middle. Anytime you have 2 lines that are intersecting, these angles that are across from each other are called vertical angles. And vertical angles are always congruent. So here are vertical angles. And then since we do have some parallel lines, so PT and SR are parallel, these lines that connect them, so ST, for instance, one of them can be considered a transversal, which means that these angles, angle T and angle S, would be considered alternate interior angles. Angle T is congruent to angle S by alternate interior angles. We could even give these some numbers just to talk about those, that angle 1 is congruent to angle 2. So this is enough. This is enough for us to say that these 2 triangles are similar to each other because they have 2 pairs of congruent corresponding angles. It would also be true to use alternate interior angles for R and P as well. Those would also be alternate interior angles with a different transversal. So anyway, these triangles are similar to each other by angle-angle similarity. Let's go ahead and write a similarity statement for these. So triangle something is similar to triangle something else. So remember, when you name your triangles, you should make sure both of them are named in a corresponding order. So let's just pick some sort of a name for this one. Let's call it TPQ. TPQ. Now that I've decided to name this one TPQ, I need to make sure that the next one is named in a corresponding manner. So angle T corresponds with S, so I need to start with S. P corresponds with R, so R goes next. And Q corresponds with Q. So again, however we name this first one, we need to make sure the next one is named in a corresponding manner. All right, cool. So not too difficult. We do need to keep in mind some of these angle relationships and be able to identify those, yeah, in any given situation. All right, let's go ahead and move forward here. And the next shortcut we have is called side-side-side similarity. So this is different from side-side-side congruence. And let's just look at it here. So it says, if three sides of one triangle are proportional to the three corresponding sides of another triangle, then the triangles are similar. So again, this is different from side-side-side congruence, because that one was if we have these two triangles, something like this, and we know that we have congruent sides and then congruent sides. This is SSS congruence. We have three corresponding congruent sides. So this is SSS congruence. Similarity is different. We're not talking about congruent sides. We're talking about the sides are proportional, meaning all of the ratios of corresponding sides are proportional. All the ratios are the same. So when we do, for instance, AB divided by DE, that's going to be the same as BC divided by EF, or AC divided by DF, that those ratios are always equal. So we will be needing to set up ratios to check this and simplifying and making sure all of those ratios are equal. So let's take a look at this. Let's take a look at side-side-side similarity in action. All right, so here we have two triangles. I'll go ahead and outline them just so that we know what we're looking at, but we have P, Q, R. We have this one, and then we have the other triangle, PSR. They do share a side, but that's not as significant here in this situation as it is for congruent triangles. So we want to figure out which sides correspond with one another. There's kind of an easy way to do this. I usually just match them up, short side with short side, middle side with middle side, long side, long side. Easy. Make sure one triangle is always on the top, and then the other triangle is always on the bottom. And so I can do that in this case. So my shortest side here is 4 or 4. Actually, the short and the middle are kind of the same in this case. So 4 and 4. And then the longest side of this red triangle is 6. And then kind of doing the same thing for my other triangle. The short sides are 6 and 6. The short in the middle. And then the longest side is 9. And then the question is, are these all equal? Let's just reduce them real quick. Obviously, 2 of them are equal. They're the same ratio, but yeah, they all simplify. So this one divides by 2. We get 2/3. This one divides by 2 as well, 2/3. And this one, they divide by 3. So we get 2/3. So because these ratios are all equal, because they are proportional, right? That's what proportional means. Proportional means equal ratio. Then these two triangles are similar by side-side-side. SSS similarity. We could go ahead and write a similarity statement for this as well. I'm not going to do that this time, but that may be something we would need to do. Again, this method we talked about up here is a pretty good one whenever you're using, whenever you're trying to figure out side-side-side. Just match them up. What's the shortest side? Put those two in a ratio. What are the middle sides? Put those in a ratio. What are the longest sides? I'll use that technique quite a bit. Okay, let's go ahead and move forward and talk about the very last shortcut that we have. So it's SAS. So this one's kind of a combination we need to have, well, let's just read it. If two sides of one triangle are proportional to two sides of another triangle and their included angles are congruent, then the triangles are similar. So kind of a combination of what we just went through. We have one congruent angle, and then the sides around it are proportional, equal ratios. Again, the thing with this one is making sure you match up the appropriate sides. So AB would go with ED, BC would go with EF. And the reason we know that is just kind of relative length, right? AB is shorter compared to BC, so it goes with the shorter one compared to this one. So again, making sure you match up the appropriate sides is kind of the key to applying SAS. All right, so here we go. We're going to verify that these two triangles are similar, and we're going to try to use SAS. So let's outline our triangles. We have first this smaller one, JKL here, right there. And then we have a bigger one, which is JMN. I'll make sure to outline that one right there. So we're trying to identify that these two are similar to one another. Well, one important thing that we'll need to notice is whenever we have an angle that is common to both of them. So angle J is the same angle in both triangles. So therefore, it's obviously going to be congruent to itself. If we were writing a proof here, we might use something like the reflexive property to justify the statement. Reflexive property of congruence. Since it's the same angle in both triangles, then it's going to be congruent to itself. Yeah, another thing that sometimes we call this was a shared angle. All right, so that's the angle part. We've taken care of the A of SAS. Now we need to talk about these sides, and we need to figure out which side goes with which side in these triangles. And again, when we're only dealing with two sides, you're only going to have a shorter side and a longer side. So just set up your ratios, short side over short side, long side over long side. It's easy. So pick one triangle to go on top. So my shorter side here is 2, and my longer side is 3. And then we'll talk about the bigger triangle. So in my bigger triangle, I guess I don't know these lengths quite yet. This side is 6, and this side is 9, right? 3 plus 6 is 9. 4 plus 2 is 6. So my shorter side over here is 6. That goes with the shorter side. And my longer side is the 9. That goes with the longer side. Are these equal ratios? Yeah, they are. Let's reduce both of them. These divide by 2. So we end up with 1 over 3. And both of these numbers divide by 3. So 1 over 3. So yeah, check. They are. They are equal ratios. So the sides are proportional. The angle is congruent. These triangles are similar by SAS. SAS. Similarity. Let's go ahead and write a similarity statement for this one, just to make sure we're in the practice of doing that. So we'll call our first one JKL. This is the smaller triangle, JKL. So obviously J corresponds to J because that was our shared angle in these two triangles. K is going to correspond with M, and N is going to correspond with L. There are a few different ways for us to make sure we knew that, right? I like to think about it in this case based on the sides. I know that side JK went with side JM. JK was the 2, right? It was right here. And that went with the 6, which was JM. So we knew that those two sides were used in a ratio together, thus they were corresponding one another. So first two letters, first two letters. Anyway, you can use the sides or the angles to sort of help you figure out what corresponds, but here is a valid similarity statement for us. All right, so next thing we're going to do is just kind of mix and match these in a few examples, figure out which one we can apply to these problems. Okay, so we are supposed to decide if the triangles are similar. So that's kind of yes or no. If it is, we finish the similarity statement and give the reason. What shortcut did we use? AA, SSS, SAS, which one? All right, so looking at number 1, this one's, I think, pretty obvious which one we should be trying. We don't know anything about the sides. The only thing we do know are some angles. So the question here is it going to be angle-angle similarity or not? Well, we have one angle and one angle. Those are definitely congruent. They're both 37. And then hopefully we notice right here in the middle a nice pair of vertical angles. So there we go. Yep, angle, angle. So let's go ahead and finish this triangle similarity statement. We have triangle JKL. So that's this one up here, JKL. Is similar to, well, J corresponds with J because those two angles are congruent to one another. K corresponds with G. And so that means that L should correspond with H. Again, use those angles to help you out there. So this one is yes. They are similar. It's angle-angle similarity. And there is our similarity statement. All right, number 2. So number 2, I think we may have a couple options here, but the first one I see is we do have an angle that's common for our two triangles. Again, we have the smaller triangle, which would be TWS or something like that. This one, we'll just make it pink for now to make it easy. So we have this triangle here, and then we have the bigger one, the one that's WVU. All right, so those are the two triangles we're talking about. And I already noted before that they do share this angle W. It's common for both triangles. So we could go ahead and try to apply SAS and see if that works. Also, it does look like we know basically all of the side lengths here, so we could just go ahead and go with SSS. Doesn't really matter. I mean, I guess technically we already know the congruent angle, so it might be a little bit easier to do this. I think I'm just going to do SSS, though, just to pick a method. All right. The only thing that I do notice here is I need to do a little calculating to figure out some of these sides, because I know the whole thing over here is 78, and then this piece TU is only 12. So 78 minus 12 is 66 for WT. And then 56 minus 7 is 49. So this side over here is 49. Okay. So now, again, I'm going to use the method of doing short over short, medium over medium, long over long. And I'm going to use my smaller triangle on top and my bigger triangle on the bottom. So for the smaller triangle, my shortest side is 48. My middle side is 49. And my longest side is 66. Okay. Same idea for the rest of these. I'm going to go ahead and talk about the bigger triangle here now. So the shortest side I have, actually I have 2 of them that are tied for 56. So those will be my short and my middle. And then my longest side is 78. And we are asking ourselves, are these ratios equal? Well, no, they're not. These two are definitely not equal. They have the same denominator, different numerators. There's no way that these are equal. So no, these sides are not proportional. So therefore, these triangles are not. So not similar triangles, unfortunately. And that's it. That's all we can do. Doesn't even really matter about this one. This one may be equal to one of these. Doesn't matter. If all of them are not equal, they're not going to be similar. All right, let's go ahead and move forward. 2 more examples here real quick before you guys get a chance to try it on your own. Okay, so looking at number 3, just kind of glancing at it, it's pretty similar to the last one we just talked about. I don't mean to use the word similar because that means something different. It's kind of like the one we did before. We don't know some of the sides, though. We actually are not given all sides, right? For instance, I don't know QR or GF. So that tells me I can't use SSS. So SSS is out of the running. I don't really know enough about the angles to do angle. Yeah, I just don't really have parallel lines or anything that are marked, so angle is just no good. So it looks like the only thing I could try here is SAS. And that does require an angle, but I can see I have some triangles here that do share angle E. That shared angle is going to be an important feature for similar triangles sometimes. As you can see, it's shown up a lot already. Okay, so it's part of this smaller triangle and the bigger one. So SAS seems like the way to go. And we do know the sides that are on either part of the angle. This is the included angle for the sides that are marked here. The only thing sort of left is I don't actually know this whole length. 13 plus 78 is 91. Wow, these measurements are wildly off in terms of like what they look like in the picture, but can't always trust the picture. We're going to trust the measurements, right? There's no way 13 and 78, that just doesn't look right. But again, can't trust the picture and got to trust the numbers. Oh, okay, so same over here. This is 91 minus 78, so actually leaves 13 for this as well. All right, so we're trying SAS. We know they do have this angle E in common, so we've kind of taken care of that. We just need to show that the sides are proportional. So I'm gonna do the same thing we've done before, short and long, short and long. I'm only doing two sides, so there won't be a middle. So my shortest side is actually they're tied, 13 and 13. So 13, 13. I guess I technically don't have a short side this time. That's okay. My longest side, 91 and 9. Okay, they're both 91. Okay, that's fine too. So these are exactly the same. There's no difference whatsoever. I don't even have to reduce them. They are equal. So these are similar by SAS. So yes, similar by SAS. And let's go ahead and finish that similarity statement. E, F, G, that's the bigger triangle. So E corresponds with R. Sorry, E corresponds to E. F corresponds with R. G corresponds to Q. And just match those up in a corresponding manner. And there we go. I'm going to go ahead and just pause for a second, let you guys take a look at the fourth one, see if you can try it, see what you can do with it. And yeah. Again, feel free to pause the video. I'm going to do the answer here real quick, but just pause it, try it on your own. Okay, so as I see this one, there's two main ways. You could use this common angle and try to go SAS. Or it does look like all the sides are kind of marked for us, so we could use side, side, side. I'm going to go with side, 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 just so I'm not mixing and matching things, and I make sure to match up all the right sides together. One thing I'm missing is I do need to know VH, so 40 minus 16 gives me 24 here. So I'm going to use all the measurements for my smaller triangle. This one that I'm going to mark red, I'm going to put those on the top of my ratios. So my shortest side is 24. Middle side is 36. Longest side is 39. Now I need to go to the bigger triangle. So the bigger triangle, I have 60, 40, 65. So my shortest side is 40. Middle side is 60. Longest side, 65. So the question we have to figure out is, are these equal? Let's start reducing them. These aren't as easy as some of the other ones we've done. These are both divisible by 8. So 24 divided by 8 is 3. 40 divided by 8 is 5. So 3/5. 36 and 60, those are both divisible by 12. 36 divided by 12 is 3. 60 divided by 12 is 5. Okay, good. 3 to 5, 3 to 5. Got those are equal, so we're good there. One last one to go about. This one's a tough one. They're both divisible by 13. Not an obvious number. 39 divided by 13 is 3. 65 divided by 13 is 5. So, yep, they're all equal ratios, so these are similar. by SSS similarity. And let's go ahead and finish this statement. HGF, HGF. That's the big one. That's going to go with HUV. Match up those corresponding parts. All right. Hopefully that wasn't too bad, guys, and I'll see you in the next one.